Hi class, today we're going to create a sample enemy script project. I'm going to put it in my Unity GitHub folder, and I want to create a new folder to hold this project. And I'm going to name it, let me cancel. Enemy class sample project. And I want to select that folder, and then I'm going to name my project that same thing. And of course, we know Unity is going to create a folder within the folder, so we'll have two folders with that same name, and that's what we want. So I'm going to create my project. It's working on it. Don't check for updates. We can't install any, right? Now I want to save my scene. We'll make this one underscore scene underscore 0, like our textbook recommends. And there, now we've got our scene saved and our project saved. I'm going to add a 3D object, just a sphere, and this is going to be our enemy. On our sphere, let me get rid of this, or at least bring up the inspector. For our sphere, let's set our transform to 0, 0, 0, all x, y, and z. Oh, just position, sorry. Now, for our enemy here, let's create a script. So I'm going to create a C# script, and we want to name this script enemy. I'm going to edit the script. And if we look at some of the components in our code here, because this chapter is about class structure, we see the using statements, we can access pre-existing code libraries, things that have been set up for us. We know that we have to have a using statement for the Unity engine to use Unity capabilities. Whenever we begin our class statement here, we can put some comments above it. We declare our class, and our class name comes immediately after the keyword class. So this class name is enemy. Now it inherits from the Unity class mono behavior, which is what gives us the capability to do a lot of the Unity things that we do. That is our game engine base class, basically, and we're inheriting from that. Now, this class statement shows that by including the colon followed by mono behavior. Now, within our class, You can have multiple methods. We use some predefined methods that Unity declares in the Mono behavior class, in our base class. So when we use these methods in our classes, we are overriding that base class method. So a method starts with an access mode, public or private. Since these don't specify, they would be private to just this class. They're followed by a keyword that indicates what type of data the method returns. In this case, they return no data, so they're set to void. The next thing is the method name, and in this case, start and update. These are methods that, as I mentioned, exist in our base class, Mono behavior, and we're overriding them or adding to them by adding them to our class. Next, we have a parameter list, which is empty, just empty parentheses for these two methods, and then open and closing curly braces to indicate that we have our method body, all of the code within our method. Now, when we're working at the class level, we can declare variables that are global to our class. These are class variables or instance variables, depending on how they're set up. So we're going to create a couple. We're going to use the float data type, and one variable is going to contain our speed, and we're going to start out with it set to a value of f, and this is in milliseconds. We're going to set up another float variable that is our fire rate, and we're going to start out with it at 0.3. It also is a float, and this is the shots per second, and it's going to stay unused at the moment, so we'll worry about that later. Line these up a little bit. So these variables, since they're public, they'll show up in our inspector for this class, the inspector variables also. Now our update method, which is called once per frame, we're going to run another method called move. It's good modular programming here. So let's declare that method. It's going to be public. We're going to call this a virtual method, and it's going to be void, meaning it doesn't return any data. Its name is move. Now we'll look at more about that virtual keyword here in a minute. This method is going to declare a vector3 variable called temp POS, temp position. Stop helping me. I'm not sure why we're getting an error there on our POS variable. We will figure it out. I'm going to keep going though. Now, in this calculation, we're doing a normal calculation to set a new position for our y coordinate, and we're going to use that speed variable and the delta time, and the delta time variable is like a time measurement since the last frame refresh. So this is going to give us an incremental amount to use to cause our movement. Again, our POS variable that's causing some issues here because it's not declared. And we're actually wanting to use a property for our POS, so we'll be getting it set up in just a second. It's causing us trouble in the meantime. Before we do that though, well, we might as well go ahead. We're going to create a property. And a property allows us to get a class variable from another class, because our class variables could be something that's private, and we're going to be using a private class variable here. We're going to, in the get method, if somebody wants to get this POS, we're going to return this dot transform dot position. So we've seen from some of our earlier code that this dot transform dot position returns the XYZ coordinates of the current object's transform position. And we're going to use this property here to get and set that variable in a standardized way. So in C#, when we declare a property, we say that this property named POS has a getter where if somebody says use the POS value in a statement, like we do here, we're going to run the getter in our POS property. So POS get is going to return the position of this current object. Now, if we put our property before an equal sign, we're going to be executing the setter. And so the setter is going to set our POS property value to this value that was passed to it. What value was passed to it? Whatever we put on this side of the equal sign. So a property allows us to access and update information that's contained or encapsulated within a C# class. So it's just a standard way of us giving access to data. Now we need another method. I'm going to put that before our property because we'd like to keep those separated. This method is going to be our onCollision enter method. Now whenever we do an onCollision enter method, we're going to receive a collision object. We're going to call that object COLL. We're going to declare another variable within this method. Now this variable has limited scope because it's declared within this method. It's only accessible within this method, whereas our class level variables are accessible by all of our methods. We're asking Unity, tell us what we collided with, and then we're going to use a switch statement to look at the tag value of that game object that we collided with. Now, if our tag is hero, we know it's not an enemy, right? So in our case statement, we'll just do a break. So we don't have anything implemented, but we could destroy the hero there if we wanted to. Now we can check for another tag, hero laser. So that'll indicate that our enemy collided with the laser of the hero. And in that case, we want to destroy our enemy, which is this game object, right? So our enemy is our current game object. Our COLL game object is the object that we collided with. Now we're going to break out of that case statement completely. We've got everything covered there for what is going on in our script for right now. Now the property is basically just a method that works like a field. That's what they say in our textbook. That's a good way of putting it. So if we use it on the right-hand side of the equal sign, we run the getter, left-hand side, run the setter. So a property just makes things much easier to use in C#. We don't have to code a bunch of get and set methods. We can just use a property to take care of all of it. Let's create another script to look at that a little bit more. I'm going to create a new C# script that's going to be named count it higher, and I'm going to edit that. There it is. Okay, so in my count it higher script, we're going to be doing a little bit more with properties. Let's set up a class level variable, and we're going to call this one, it's going to be private, and we're going to set it as an integer, and it's underscore num. We'll set its value to 0. Now in our update method, we're going to print a value called next num. Now, right now we're getting an error because we don't have that value, so let's supply it. It's going to be a property. So in this property, we're only going to have a getter, so we're not going to allow any external updates of our property, only our own updates. So in our getter, we're going to update the value of num first, and then return underscore num to our caller. But let's create one more method. I'm going to label some things here if you like. Here's the end of our update method. And then our getter and setter has some interesting curly braces. Here's the end of the getter. And here's the end of our next known property. So right after that, I want to create a method. We'll call it current num. And in current num, oops, I don't need parentheses because we're going to make this a getter and a setter. Current num, whenever we do a get, we're going to return underscore num. These parentheses should be curly braces. Now this is just a shortcut version of the get and set statements. And we're going to set by saying that if somebody passes us a value, we want to set underscore num equal to that value. Now that finishes our getter and setter. So just a little bit different of syntax for us to use. Now the way this is going to work, if anybody tries to get our value of num, we're going to update it by adding one to it. And then if somebody tries to get what the current value is, current num, we're just going to return that value to them. So let's go back to Unity. I want to save everything here in Visual Studio. Looking at the instructions a little bit, I want our count it higher script to be associated with our sphere. Now let's run our game. We shouldn't have much going on here. Do you see anything happening? go. So our count it higher script is outputting these numbers. Why is that? Because in count it higher, every time the update is run, we're running our script. Every time update, we're printing out next num. When we access next num, we add to num. So it just keeps getting updated. Not actually ever using this current num, though, anywhere right yet. So maybe we'll be doing that soon. So let's make our enemy do some things. Now we've got this great counter going and all of this stuff. So we're learning some things about classes and getters and setters and all this great things. Whenever we are working with a class, that class instance is actually a game, can be a game object component. So every time we see a new instance of an enemy or of our sphere, we are seeing a new instance of that script also. It's associated with it. So let's see. Let's create another new script, and we're going to call it Move Along. Now, I want you to open the red one. It's opening the one from before, huh? In my Move Along script, we're going to have a method override for the late update. And the late update is the update method that runs after all other updates are completed. Now, in our late update, we're going to use our count it higher script that we created earlier. We're going to call the instance of count it higher CIH. We're going to use the Unity get component capability to find the running instance of that script. Now, if when we look at the running instance of our count it higher script, if we find one, it's not null. If it is null, that means that we couldn't find it running. But we did find it running. So we're going to set up a float variable called tx. And we're going to use our count it higher script's current number, that one that we hadn't used yet. We're going to access that data and divide it by 10. So remember that current number is moving as time passes, it's incrementing. Doesn't like my POS property, let's create it. I'm going to go to the end of my late update script. I should start at the end of these methods apparently. We'll create it. It's going to be the same as it was earlier. Vector 3, and for our getter, whoops, we're going to return this .transform .position. And for our setter, we're going to set this .transform .position equal to whatever value is passed in. So that takes care of our getter and setter. Now we shouldn't get these silly errors. So we're going to use our position property to take care of setting up that location. We're going to update the x coordinate of our location equal to this temporary x position we've calculated. And then we're going to use our setter to update our transform position. Now, every late update, this code will find the count it higher script and then pull the current number from it. The script will divide current num by 10 and set the x object. So we should be seeing some movement. We want to save this script. Let's see if we've got anything happening now in our Unity game. No, I'm not moving along. Do we need to add that to something? Let's see. We need to add move it along to our enemy, right? So let's put that on our sphere. See if we can move it along. There we go. That's a little better. I'm going to rename my sphere here to enemy. So now our move along script is associated with our sphere. So every time we create an instance of this enemy, of this sphere, it basically has its own copy of this move along script going along with it, and it can do all of those things independently of other instances. So we can have everything working on its own. Let's copy it. And now let's move enemy one's start position a little bit and start our game. And we should see them both moving. And of course they're moving right together, right? Because we have them set at the same increment. I could move my other game object over a little bit. Put it back to the same place, right? So I've got some transform going on there. I'll delete that one. Just be aware that each instance of that object then has that script associated with it. Now we want to be aware of some things that can happen in Unity because of that. Whenever we have multiple scripts going on and scripts associated with different things, we need to be aware of race conditions. And a race condition can happen anytime we have two things that rely on each other. We could get into a spot where we're not exactly sure which one will happen first. So that's why we use late update in that example. If we'd used update, we wouldn't be sure whether the update and count it higher or move along would be called by Unity first. So we wouldn't really know if our movement would be appropriate. So we needed to make sure that all of those updates had occurred before we ran our move along script. So those race conditions are something that can give us some interesting results. So let's implement this thing. I'm going to create a new scene. Let's save this scene. This is going to be underscore underscore 1. We want a new sphere. I'm going to rename my sphere to be enemy GO for game object. Now this sphere is not connected in any way to this sphere in scene 0, so it doesn't have any scripts set or anything. So let's set its transform position first. I want it to be position 040, and drag the enemy script that you wrote earlier onto your enemy. Now if you look at enemy GO in your hierarchy, over here on your inspector you should see your script here, and we see our inspector variables that we can modify. Let's drag our enemy onto our project pane to create a prefab. Now let's fix up our main camera. Our main camera, we're going to do some changes with it a little bit. So let's set it to 0, -15, -10. And 0, 0, 0, and 1, 1, 1. So that all looks good. We want our background to be a solid color instead of that sky box. And they have this blue. That's fine. You can change it if you like. If you want it to be a different color. Let's change it. Come on, imaging easily. I don't know why my eyedropper. There it goes. Make mine a super in the rain orangey yellow. I don't know why. I'm going to take it. The new color. Well, I'm obviously doing something it doesn't like. Give me a color, please. Forget it. Hates my color. So I'm just going to keep going because I don't want you guys to laugh. And I'm sure you are. That's fine. You go ahead and laugh. Now the other things that I want set. I want it to be orthographic. And we want our size to be 20. Then bird's eye view. Now let's see our viewport rectangle. That all looks good. Depth -1. Good. Instead of using graphics setting, it says to use player settings. Don't see that. So we'll just leave it. Okay. Oh, that looks good. Click play. My enemy is moving down the screen at a constant rate as expected. So I'm going to stop that. Now, whenever we were looking earlier, I told you that we inherit from, look at that, our Unity base class, mono behavior, when we're working in Unity. We can actually create scripts that inherit or derive from our own personal scripts. So let's do that. Let's create one. We're going to call this script enemy zig. And I don't want to do that. I keep doing in enemy zig, we're going to be doing some movement, but we want this to affect our enemy. So instead of inheriting from our mono behavior, we're going to change this to inherit from our enemy script. Kind of like adding a tag along. So our enemy script now becomes our base class or our super class, and enemy zig becomes a child class. Now we want to delete all of the default code here. Just going to leave my open and closing curly braces for my class statement. And I want to create a 3D object. We bounce back and forth here just a little bit. We can handle that. Game object, 3D object, and let's create a cube. Now our cube, let's call our cube enemy zig game object. Now for our enemy zig, our cube, let's set our position to -4, 4, 0. We want to use our enemy zig script for this game object, so we'll drag it on there. And then we want to create a prefab. So let's move this down to our assets window. Now let's play our game. It says that enemy zig go should have all of the behaviors of our enemy, but it doesn't seem to, huh? Meaning that it should be falling. Oh, look, let me go back to my enemy zig script. It still contains the start and the update methods. So I need to save here in Visual Studio to take those out. So those were overriding the start and the update methods of the parent, our enemies. So now when we run, we should see the same behavior from both objects. So our child is inheriting all of the behavior from its parent, since we didn't try to override any of that behavior. So we can see how that works. Now we want to update our enemy zig script. So for our enemy zig, we're just going to put in a move method. Let's see what we need. We're going to override the move method that we have in our enemy script. So in our enemy script, we could actually run our enemy script by using this statement, base.move. That would run the method in our base class, or our parent class. But we want to do something different in this child class. That's a component of polymorphism. It lets us take what's in the parent class, the move method, and change it for this class. Now it's using the POS property of our parent class, so we're not getting any errors on that. And this time, we're going to use some different calculations to determine our movement. So we use this calculation here that uses some sine type calculations against the value of pi to determine our movement. We'll set our position. Now, in this case, we have to actually issue the code to run the move method in our base class. let's see how that all works now. I'm going to save it. So nice. Now we see that they're both moving at the same rate, and we can control that child a little different. So what did we want to see here? That we can use these classes to combine data with functionality. That's what object-oriented programming is about. And this lets us really exploit all of these available libraries so we can do anything that we want. Now, sometimes we might do things a little bit more efficiently in the real world. In our textbook, we might do things, for example, that might be a little bit less than perfectly efficient. So don't be surprised if you run across things like that. It's all part of the learning process. Now, these enemies don't do any shooting or anything like that, but they give us a good basic understanding of how we can set up some default scripts, inherit from those scripts if we want to extend our capabilities and get things started really quickly with Unity. So thanks.